Hello folks, we are going to talk about user datagram protocol. It is another widely used layer 4 protocol, and because it is widely used, there are of course going to be many UDP based attacks. So again, as a security analyst, you have to know what normal UDP datagram look like, how UDP should function, and by doing so, you will be able to recognize an abnormal datagram that could have a hidden threat contained in it. We also need to understand the difference between TCP and UDP, and the reason for this is so that you are able to distinguish TCP actively versus UDP actively. Now, as far as UDP characteristics go, UDP does of course operate at layer 4 of the OSI model, and so it is operating at the same layer as TCP, but its functionality differs. So where TCP was providing us with connection-oriented services, UDP provides us with what we would consider connectionless. It is a one-way datagram. It doesn't establish a full duplex mode of communication. Now UDP does use IP protocol number 17. So if we were to go down a layer and we were to look at an IP header, the protocol feed would point on to protocol 70. Now, the reason that we look UDP is because it provides efficient access to the network layer without that overhead that we would see with TCP. So we don't have the reliability. We don't need the reliability mechanism. UDP is all about efficient access to that network layer. Now again, it is a connectionless protocol. It's a one-way datagram. There is no notification that it made it to the destination, but that's okay because what happened is the upper layer, the application that is using UDP, will let us know if we received the information or not. Now UDP is sort of limited in its error checking capability. It does have an optional checksum value that is optional in IP version 4, but it is been made a requirement in IP version 6. Now in addition to this limited error checking, you should know that UDP is sent on the best effort basis, so no guaranteeing of data delivery packet could be corrupted in transit. They could be misdirected in transit. They could be lost along the way. UDP doesn't have any special feature that will recover from that if it were to happen. So for all of that, we are going to rely on the upper layer application to handle any error correction and detection and retransmission. UDP doesn't do that for us. Again, UDP is all about giving us fast, efficient access to the network layer. So if we were going to provide you with an analogy, it would be very similar to using the postal service to send the letter versus a carrier service to send something certified. If a carrier services send it certified, you get a notification that it has been delivered. That's just like TCP. However, with UDP, once you put a stamp on the envelope, address it, put it into the mailbox, it's up to the postal service to deliver it. And we don't know if it is going to get there or not. The only way we know is if the application, so in this analogy, it would be person receiving the mail. Let us know what they received it. Now, what kind of application would use UDP? Well, there is application, a number of application. One application that is often used in data networking is TFTP. This is the trivial file transfer protocol, and it is a very simple transfer protocol, and it is used to copy operating system, and many network services also use TFTP. It could also act as a TFTP client, and we could copy files back and forth in this manner. We could copy an image to the device or off to the device to back it up, especially in switches and router. So TFTP as an application itself is not as bulky as the file transfer protocol or FTP. FTP does authentication. TFTP doesn't. does its own error checking and sequence numbering. It doesn't need the reliability of the transport layer, so therefore UDP is a perfect fit for the TFTP. Now when it comes to SNMP, that is another protocol that uses UDP, or another application that uses UDP. Now SNMP is a simple network management protocol. This is a protocol that is used to monitor and manage our network devices. SNMP sends protocol data units or PDU that let me monitor and control network devices. Again, UDP is a perfect fit for this device, for this protocol, because SNMP will handle the error checking and sequencing and so on. Another protocol is DNS, the domain name system. This resolves our IP addresses from human readable names. So, for example, www.abc.com has an IP address associated with it. When we type in abc.com and hit enter in our web browser, we are going to use the DNS application in the background to figure out what the IP address is of abc.com, so that we can actually send it to the right place. So DNS can use either TCP or UDP. When we do name resolution, it uses UDP in most cases. That is faster than TCP. Again, it is faster because we don't have to establish a three-way handshake. We don't have to worry about all of the reliability mechanisms that are built into TCP. But if we have message where the size is going to be bigger than the DNS protocol's limits, and we are going to need reliable service, then DNS can use TCP. Another protocol that we have that uses UDP is the network time protocol. This simple protocol synchronizes time from a server that is out on the internet or some other sources. It could be a router that you have deemed to be the NTP server. So again, this is a protocol that does not need to be reliable. So UDP is a perfect fit. So all right, so that's just an example of 4 different applications that uses UDP. Let's take a look at the UDP header. The UDP header is much more lightweight and streamlined than the TCP header would be. And that is simply because we don't have all those reliability mechanisms. All we need is that 16-bit source port, 16-bit destination port, and 16-bit UDP length, 16-bit UDP checksum, and the rest is data. Again, it is good to understand this UDP header. The format most attack against UDP are going to be using these fields in a way that UDP was not intended to be used, or they are going to be trying to hide themselves covertly in UDP packets. So this was all from the UDP. See you in next lecture of TCP and UDP ports. Thank you.